I mentioned this earlier, 24th. Today we got trig ratios, trigonometric ratios, how to side ratios and right triangles to find trigonometric ratios. And we're going to find the sine, cosine, and tangent of an acute angle, use trigonometric ratios to find side lengths and right triangles, and solve real world problems. Our key terms are trigonometric ratios, sine, cosine, and tangent. Right? If you didn't get this down, I'll give you a chance to here after class. Of course. All right, first up. It says, by the angle-angle similarity postulate, a right triangle with a given acute angle is similar to every other right triangle with that same acute angle measure. Yes, ma'am? Yes. So, triangle ABC is similar to triangle DEF, is similar to triangle XYZ, and BC over AC is proportional to EF over DF is proportional to YZ over XZ. These are called trigonometric ratios. Key part down there at the bottom. A trig ratio, are you kidding me, is simply a ratio of two sides of a right triangle. Okay? Two sides of a right triangle. Question. This is 90. This is 32 degrees. How much is angle Z?
Hang on. 90. Let's see.
I got it. 58 degrees, right? It's 58 degrees in each of these particular triangles, right? Okay.
Yes.
So I want everybody to hear me out. Why trig ratios are true is because sides of similar triangles are proportional.
Gordon.
They're proportional, okay? That's what makes these trig ratios true. Alright, here are your trig ratios. Sine of an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. The cosine of an angle is the ratio of the length of the leg adjacent to the angle to the length of the hypotenuse. The tangent of an angle is the ratio of the length of the leg opposite the angle to the length of the leg adjacent to the angle. Sine, cosine, tangent. Yes, I know it says sin, cos, and tan, but it's an abbreviated form of sine, cosine, and tangent. You need to write down this entire slide.
How much time do you get?
You're going to get as much time as you need.
Thank you.
About 4 minutes.
I need it.
All right, one last thing you got to remember. Sine, cosine, and tangent. Okay, these are ratios. These represent ratios. They are on your formula sheet. Come on now, I wasn't done. It's done now. All right, they are on your formula sheet, and here is how you will see them written. You'll see them written as the sine of theta, the cosine of theta, and the tangent of theta.
You get jealous real easily.
Not the last
Let me
time.
get a picture of this real quick.
All right. So when we say theta, anybody know what that means?
Eternity.
It is Latin. Okay. Guys, theta represents an angle measurement or a degree measurement. Okay? Theta represents an angle or a degree measurement. So when we say the tangent of A, okay, we're talking about angle A. So you got to read your theta to understand in this context it's going to mean an angle measurement. Right. The letter of the vertex of the angle is often used to represent the measure of that angle. For example, the sine of angle A is written as sine A. Right? That's going to be really key to understanding what's going on here. Now, there is a certain faux phrase that you can use to remember your trig ratios. It's an Indian word, SOHCAHTOA. Okay? SOHCAHTOA. Now, when the Germans came over on the Mayflower and met Squanto and the SOHCAHTOANs. Oh, good. See, usually it takes at least 2 minutes before somebody. Yeah, but they were what? They were Italians, right?
Yeah, no. You almost got me again. That was a good one.
Pilgrims, good. Pilgrims and Squanto. Yeah, most of these jokes are catered towards the fall because this is about where we get leading up to Thanksgiving / Halloween, whatever it may be. Alright, good. So I won't even have to run through my mill
So
of
we're
bad
gonna have a
jokes,
Halloween
okay?
party in March.
SOHCAHTOA. Here's why we call the trig ratios SOHCAHTOA. Right? The sine ratio is opposite over hypotenuse. The cosine ratio, Miss Ballou, is what? Adjacent over hypotenuse. And the tangent ratio is opposite over adjacent. You get SOHCAHTOA out of this.
Is the theta adjacent or is it the opposite line?
So theta is right here.
In a triangle.
It will vary. So understand, theta would change every single problem. We would have the sine of A, the sine of B. Okay? And it's going to be 2 different ratios. Right? Here are, Cameron, you need to put your phone up. Everybody needs to put your phone up. If you got your phone out, I have 0 sympathy for you next Friday. When some of you, that crushing reality of your A turning into a B or a C will hit. And I'm being dead serious with you. You can't cruise through trigonometry. But good luck. Yes. Yeah, that's fine. Alright? Alright. Couple of different ways to remember these SOHCAHTOA. Number 1. Some old hippie came around here tripping on acid.
That's so good. I like that.
Some old hippie came around here tripping on acid. Alright? Or, if you so prefer, some old hag came around here to offer assistance. Some old hag came around here to offer assistance. Assistance. Okay? So you can do hippies or hags, however you like. You can do acid or assistance. So whatever you need to do, okay? Alright, hey. Lucky for you guys, the sine, cosine, and tangent, the trig ratios, are located on your formula sheet. You look down at right below the Pythagorean theorem. Sorry, balls. Okay, it says trig ratios, sine of theta, cosine of theta, tangent of theta, so on and so forth. Okay, so you don't have to memorize them. That's what's good, right? But you're gonna want to write these down several times. All right, let's talk about this. Write the trig ratio as a fraction and as a decimal rounded to the nearest hundredth. All right, I said yesterday, the first thing to do in every right triangle problem is to identify the what? The hypotenuse. Well, it's a right triangle. How do I know it's a right triangle?
You see the square.
Got a right angle. How do I find the hypotenuse? There you go. Go straight across from the right angle. Put an H. That is your hypotenuse. Okay? That is always your hypotenuse. It does not matter which angle you switch to, that is your
You're
hypotenuse.
still splitting?
Yep.
Alright.
First thing to do is always find a hypotenuse. This is where a lot of people will get confused, so this is why I beg you to pay attention. If I want to find the sine of J, okay, here's what I have to do. I have to go to angle J, which is right here, and I've got to find two sides of the triangle. First off, I need to go across from angle J and find the opposite side. And then I need to go next to angle J and find what's called the adjacent side.
Why do you have an O?
O is for opposite, A is for adjacent. Opposite, adjacent. Yes, ma'am.
What are you even saying right now?
Okay, talking to you about trigonometry. Opposite side and adjacent side of angle J. Notice which particular letter didn't change.
Okay.
The H. Okay? Your hypotenuse would stay the same. Okay? What is the sine ratio?
J.
Opposite over,
Adjacent.
okay? Opposite over
Adjacent.
hypotenuse.
What the crap?
Okay? Again, if you're not paying attention, you're not going to get it. And I'm telling you, you're going to really hate your life over the weekend and all next week. Alright? From here, guys, all I have to do is sine of J is opposite over hypotenuse. What number is associated with the opposite side? What number is associated with the hypotenuse? 61. In the warm-up, which a lot of you weren't here for, we converted that fraction to a decimal. Just type it into your calculator. Give me the first two digits. What are they?
Hang on.
0.98.
That's all you gotta do?
3605
That's it.
655.
To find the trig ratio, that's all you got to do. Okay. Alright, next, I look at cosine of J.
Hang on. Is this all one problem, or is like we got to
That would be one problem. This would be one problem, this would be second, this would be third. Okay?
How do you
Not
know what
one.
Phil.
Okay? Sine J is just talking about angle J. I could also ask you about sine K, but we're going to get to that in just a second, okay? Alright? The cosine ratio is what? Adjacent over hypotenuse. What letter is associated with A? I'm sorry, what number is associated with A?
11.
11. What about H?
61.
Okay, what is that
11.
as a decimal?
What the f-
0.18. Right?
The next is opposite and adjacent.
Alright, now, you're almost right. It is opposite and adjacent, but there's a problem. My theta has changed. No longer J, it is now K.
But you ain't got it.
So when I change my theta, I've got to come back over here. Look at this. The hypotenuse stays the same, correct?
Right.
But I go from angle K, and now 11 is the opposite side, and 60 is the adjacent side.
Hey, can you go back over that one more time?
That's gonna confuse the crap out
So
of me.
what's adjacent?
So it'd be 11 out of 60.
If you have a question, raise your hand. Yes, sir.
Can you go back over that one more time?
Yes, ma'am.
How do I identify adjacent?
Next to. Yes, ma'am.
What does any of this mean?
Okay.
But there's two.
T-H-E-T-A. Alright, here's how we'll do this again. Alright?
You said go to the
I,
opposite.
I'm in angle K right now. This is considered, because it's the tangent of K, that is my theta, okay? So, since I have a new theta, because this was sine of J and cosine of J, since I have a new theta, I have to find a new opposite side and a new adjacent side. In this case, what I'll do is I'll start an angle K, and I will go all the way across the triangle for the opposite side. The adjacent side is going to be which side is right next to my angle.
Isn't
So how do you know which
side
one?
KJ technically right next to your angle?
Sure, but it's the what?
Oh, it don't change. That's one.
It's the hypotenuse. That's why the first thing you do is always find the hypotenuse. It never changes. Okay?
Can you use trigonometry on
No, just right triangles. So
So
actually, you'll see how you use it in circles next year.
so if you do L, what would be the opposite of L?
All right, hold on one second. That's a good question. Let me answer the problem first, and then I'll get to that. All right, what is the opposite side of K? 11. What is the adjacent side?
60.
60. What is 11 over 60?
Stop.
Do what?
It was 18 and repeating 3.
Plus 1/8 with a repeating 3. I'd say plus 1/8.
Okay.
You
All right,
gotta add the line, Mr.
really close. Not quite the same. Shouldn't be quite the exact same ratio, but it's close. All right. Mr. Hesterly brings up a great point. He said, what about angle L? How do we find opposite adjacent for angle L? Here is a huge takeaway. You don't.
Wait, I thought
Pretty
You
good.
never have an opposite or adjacent for the right angle. Trig ratios are only available for the non-right angles. They're also known as the complementary angles of right triangles. Okay? Got me? So in every right triangle problem, you're going to identify the right angle is what's going to pop out, and you got to know, guys, you're never going to have a sine, cosine, or tangent for L. Okay?
So if we ever see
Thank
like
God.
cosine or
Unless they ever.
Do what?
so if we ever see like find the cosine of L or something, you just put like
No.
positive.
You won't see it. Okay? Alright. Everybody get your calculator out. Get your calculator out. It says, use your calculator. In your calculator, not your phone, but your calculator, you will find sine, cosine, and tangent.
I see it right there.
They are located approximately 2 rows above the AC delete button. Yeah, I'll turn the lights on. Alright, here's how you solve these problems. Again, you probably can't do them in your phone. You probably need to get your calculator out. So, this is maybe the easiest thing we do in here, and believe it or not, it's on your EOC.
I found the
Okay?
sign.
Hit the SIN button on your calculator,
.79.
and then type in 52, and then hit enter.
It's .79. .79 rounded. Rounded.
0.78 what?
801.
Okay? What about cosine of 19? 0.94? What about tangent
Oh, it's
65?
.95, ain't it?
2.14.
Tangent 65.
Yeah, it's 2.1.
It's 2.1.
Hold on.
That cosine, whatever it is, ain't that supposed to be .95?
It's 2.1.
Go ahead.
2.14, right?
Yeah.
Any questions on that? Yes.
Cosine is wrong.
0.95.
So when the,
Easy.
call them, when their numbers is no one trying to like,
Say what?
the numbers, I forgot what they're called.
Thetas?
If those are letters and we have a triangle, can we still use a calculator?
You're always gonna be able to use your calculator.
It's a way you can do it.
We haven't even gotten really to real problems yet, so y'all just hold off. Hold off 1 second for me, alright? Alright. Hypotenuse, we already know, is always the longest side of the triangle. The denominator of a sine or cosine ratio is always greater than the numerator. What? Why would that make sense? Why would the denominator of sine or cosine always be bigger than the numerator?
So you can divide it.
Stuff camera.
What's my sine and cosine ratio?
You got
Sine,
some.
And cosine is adjacent over.
So read the first sentence and then tell me why the second sentence has to be true.
Because the right triangle is along the side. Wait.
Cause it's gotta be hot.
Because the hypotenuse is always along the side.
Hypotenuse
It's always
is
on the
always
bottom.
the longest side, and it's always on the bottom.
Let's go.
So no matter what, your hypotenuse has to be greater than your opposite or your adjacent sides. Right?
Yeah, but I'm confused.
The
Sine.
sine and cosine of an acute angle are always positive numbers less than 1. Since the tangent of an acute angle is the ratio of the lengths of the legs, it can have any value greater than 0, okay? There's going to be this mixed bag of things that start coming into play. One of the things you need to know, if you're dealing with sine or cosine, you're always going to have a decimal less than 1, bigger than 0. Okay? Everybody with me? Always have a decimal less than 1, bigger than 0. Hi. Yeah. Always going to be points. Yeah, you're going to be rounding a lot. Alright, here we go. Here is your first trig problem. Okay? Here's your first trig problem. Please watch me. If you have any questions, write them down or ask as I go through this problem. You ready? Find the length of BC, round to the nearest 10th. Nope, nearest 100. Okay? Every single right triangle problem. Identify the right angle, go across from it, label my hypotenuse. Right? Okay? Check it out. If I have an angle measurement, like I do in this case, angle B, I want to go to the angle measurement because this will represent my theta. Alright? I'm going to use 15 as my theta. If I'm using angle B, I now want to identify my opposite side and my adjacent side. I don't know what the adjacent side is. Which side am I looking for? Am I looking for O, H, or A? A. Okay, I'm looking for BC. BC is right here, correct? That is BC. It is my adjacent side of the triangle, right? I'm given which side? Opposite or hypotenuse? So, if I'm given opposite and I'm looking for adjacent, which of the 3 trig ratios deal with opposite and adjacent? Tangent. Tangent equals opposite over adjacent.
I never get
right? Your tangent of theta, correct? Right? Let's see if we can get this down. Okay? Your tangent of theta. In this case, what angle did I use for theta? B. So I used the tangent of B. Do I know the measurement of B?
15.
It's 15. So I put tangent of 15 equals opposite over adjacent. I'm going to move this whole thing up here. Okay? From there, fill in what information you already know. Do you know anything about the opposite side?
10.2B.
Do you know anything
No.
about the adjacent side?
No.
So watch how this works. Tangent of 15 equals 10.2 over A.
Oh yeah, I can do that.
Alright? What do we do? In this situation, I'm trying to solve for A. What can I do to tangent 15?
Yeah, I was thinking.
Do what? You can put it over 1, and you're going to be able to cross multiply.
0.6.
Okay? Alright.
I think it's tangent 15.
How is tangent of 15 a thing, right? Get your calculator and type in tangent 15.
Oh, I got
Tangent 15.
Oh, it's really just a long decimal, right?
Oh, what?
No, it's like a little square.
So,
0.27.
check this out. When I multiply, when I cross multiply here, I get 10.2 equals tangent of 15 times A. To solve for A, I will divide both sides by the tangent of 15. And if you want to, again, after about 100 times of doing this, you're going to see your shortcut. If your variable is in the denominator, you just have to switch your variable with your trig ratio. See this? See how I ended up? All right. In your calculator, type in 10.2 divided by tangent 15.
6. No, 0.7.
Nope.
What?
38.0.
38.06.
Y'all
Six
are
what?
wrong.
066.
69.
38.07. Okay? Your final answer is 38.07.
Oh, okay.
Okay? That's your final answer. So what is the measure of BC?
38.
38.07. Okay? Your first trick problem, guys. Consider yourselves grown-ups now. Alright? Yeah, it's not going to be easy. I'm trying to tell you this. It's not going to be something that you just get to stumble upon and get on through. Alright? You're going to have to take time, and you can't miss a single step of that process. You can't miss the hypotenuse, you can't miss the adjacent side, the opposite side, the wrong ratio, you can't screw up the angle measurement, you can't screw up the ratio you plug in, and you can't screw up cross multiplying. Got me? If any of those things are wrong, you're wrong. That's what's tough about this, okay? That's why it's complex. It's not complicated, right?
Yeah.
It's actually really not complicated at all. Find the hypotenuse, find an adjacent, find an opposite side, plug in the right ratio. Not complicated. Complex? Yeah, pretty complex. What's up? Sure. Give me just a second. I'm going to do it in a different problem, okay? All right. 38.07.
QR.
Find the length of QR, round to the nearest hundredth. I will model a second problem for you. Let's see how well you follow along with me.
The hypotenuse is 12.9.
First thing I do is identify the what? Give me my hypotenuse, correct?
12.9.
Okay? After I've gotten my hypotenuse, right, I want to then identify a theta that I should use.
63.
Okay, and what angle is that?
P.
Angle P, right? So go to angle P. Let's go ahead and figure this out. Mr. West, if I go across from angle P, I get what side? Opposite side. Miss Bridges, that means that this side right here has to be the what? Adjacent side, right? You only got 3 letters, guys. One of the things you can do if it helps you out, every single problem, you got to go through a hypotenuse, an opposite, and adjacent. And you can mark them off. I did the hypotenuse, I did the opposite, the only thing left is the adjacent.
Wait, is there always going to be an angle in them?
Has to, well, until next week.
You see, this is your fault.
One of the things that we'll do next week is called inverse
So
sine
the one
cosine
opposite of
tangent.
the angle is the opposite, and then the one opposite, no wait, the one to the right of that, or to the other.
Stop.
Yeah.
Alright. Then you ask yourself, what ratio do I use? What ratio, well, let me ask you this. What side are you looking for? Hypotenuse, opposite, or adjacent? You're looking for the opposite side, correct? So you're looking for the opposite side. What side do you have right now? You have the what? You have the hypotenuse, correct? So which ratio deals with opposite and hypotenuse? Sine. sine of theta equals opposite over hypotenuse. Watch how it works. Sine of theta equals opposite over hypotenuse. The sine of P is the opposite over the hypotenuse. Oh wait, Snapdragon, the sine of 63 equals opposite, which we don't know, over hypotenuse, which is 12.9. Now, Mr. Hesterly, you wanted to have me review cross multiplying. No problem. I can put sine of 63 over 1, because I can create a fraction out of anything. Okay? Once I do that, it's just a regular old cross multiplication. This is O, alright, not 0, but O. So opposite would equal 1. When I multiply sine 63 times 12.9.
812.7.
What you get? What is it?
812.7.
8.12?
No, 812.7.
No.
I got
63.
What?
Oh,
11.49.
oh, it's good. Fine.
Alright? Alright. Let me ask you a question. You do this problem, and all of a sudden, you you get 16 as your answer. 16.46. Automatically, why do you know that's wrong? Because it's bigger than the hypotenuse.
Oh, because the
Hypotenuse has to be the what? Got me? Okay? So that's another thing you gotta think about when you're solving these trig problems. Is my hypotenuse the longest side? Guess what? If it's not, you've messed up. Okay? Not, you've messed up. Let me see how much more we've got.
Take a break.
Yeah, that's a great one.
Yeah, that's a great idea.
I think that's a
Take
good
like a 10
idea.
minute break and then do that problem we just passed.
Good lord, we have to
that
do
one- that
today.
one-
We still got that much
that's
left?
So, hey, so I'll take.
Guys, I won't spend too much time on this, but I will tell you this.
If the.
The first thing you do is identify the
Hey, you
hypotenuse,
don't know it.
and we'll see how well you guys do from there. Alright,
Spread the legs.
I
Shove it.
please get off your phones. Thank you.
Yeah, Gordon.
I had high expectations for you as far as your word problems were concerned. I think a little bit too much. If I get a word problem, what should I probably do? Probably should draw a picture, right?
What is that P word?
Well, you should read it first.
Polotzbahn, the Polotzbahn, I don't know. World's steepest cog railway. Its steepest section makes an angle of about 25.6 degrees with the horizontal and rises about 0.9 kilometers. To the nearest hundredth of a kilometer, how long is this section of the railway track? I will tell you right now, the hardest part of this problem is not going to be anything other than drawing your picture, right?
Right.
If I asked you guys right now to draw a picture of this, I hope you would get something like this.
Oh, I was about to draw that.
Okay?
Yeah.
Notice this. Notice that the angle it talks about is down here,
Oh, gravel.
right? And the thing that most people miss is this. It rises about 0.9. A lot of people want to put 0.9 as the hypotenuse.
But
That's
it's
not, that does not indicate rise. Okay?
Hypotenuse is missing.
The hypotenuse is the part that you're trying to solve for here.
I'm getting good at this.
You are. Everybody should. Alright? Alright, here we go. I want you to do 3 and 4. I want you to do it in about 30 seconds. Ready? Go.
But
I'm gonna give you a couple more minutes, and I want you to, I want you to do 5 and 6. 5 and 6, I'll give you 5 minutes. So, hopefully you got this far. You can identify the hypotenuse. Again, I'm not trying to be mean or coy with you. If you can't identify hypotenuse, you're in the wrong class. Okay? It's going too fast for you. Alright? From there we gotta think about, again, you go through this process every time you do one of these problems. And the sooner you believe me and the sooner you start doing it, the easier it gets. I have to have a theta. My theta is going to be the angle of reference, the angle that I use to determine an opposite side and an adjacent side. I want to use a theta, if I can, that I'm given the angle measurement. In this case, I would use angle A, and angle A is 22 degrees. Right? I want to go through that entire process before I do anything else. If I get angle A, I will go across angle A to find the opposite side, and I will go right next door to find the adjacent side. I then have two questions for you. First, what is CB? Second, what is AC? To find CB, you need a ratio that involves opposite and adjacent. Why would I choose adjacent and not hypotenuse? Yeah, because I already have it. I'm not given the hypotenuse. You got me? That is the whole thing we're looking at when we look at trigonometry. All right? That single piece is what you got to have. Okay? But since I'm given since I'm given the adjacent, I can plug in my tangent ratio and say tangent of 22 is going to equal O over 15, because that's O over A. I'll set this over 1. I'll cross multiply this below. What is tangent 22 times 15? Below.
I get 6.06.
What'd you get?
I got one to make.
Okay, so when you're doing these, make sure that you close your parentheses after you do your angle measurement. So it's tangent 22. You'll type in tan, it'll come up like that. You'll put 22, close it,
6.06.
times 15. 6.01.
6.01. Or no, 1. Because 6 1.
Oh something. 6.06?
Is that, over 15, is that opposite or?
She's saying the 6 rounds up.
Oh, it is, and there's 10. 6.1. Good call. O is opposite. That's O is for opposite. Okay? Alright. So this is 6.16, correct? Or, sorry, 6.1. Guys, do not miss this. Please don't miss this. The next question says, find AC. What's going to be the easiest way to find that? The Pythagorean theorem. How many of you plugged in the Pythagorean theorem? Right? Hey, 15 squared plus approximately 6.1 squared equals AC squared, aka hypotenuse squared, right? How many got that far? Alright, what'd you do? What'd you get?
For CB.
Yeah, no, for AC. No.
Oh no,
15 squared is 225. You what?
I got them mixed up. I got 5.6 for the other answer.
Why do you think, let's think about this. Why is 5.6, what I know right now, that's not a good answer.
Why did you put it into the calculator?
Yeah, Gray? It's got to be longer than 15. It's got to be longer than 15 because the hypotenuse is always the longest side.
Yeah.
Okay? Let's do this real quick. Give me 6.1 squared. I'll do 15 squared. It's 225.
It's
37.21 h squared. Somebody tell me what 225 plus 37.21 is. 262.29? 21? Give me the square root of that. 16.19. Okay? Is 16.19 a sensible, educated answer?
Yeah.
It fits all the things I'm looking for in a hypotenuse, right? It's the longest of the three sides, correct?
Right.
Okay? It would fit in with this particular ratio.
Well,